per thread and more resources per block. I think everybody always wants more registers, so probably next time each SM will have another 32,000 registers. That's my guess. Bigger caches, more shared memory. There's a kind of a tension between cache hierarchy and shared memory. And again, there's the religious arguments where each person on each side of that is very, very passionate and believes the other people are dummies. And they don't know what they're doing. I think we'll continue to support both, but I think we'll probably need to move to even more flexibility about the configurability of more cache or more kind of shared scratchpad. The programming model and the hardware needs to become more flexible, fewer and shallower cliffs for performance and functionality, easier to tune for. So two goals are make it easier to write a CUDA program and make it easier to write a fast CUDA program without as much optimization. So the programming model will evolve to support that, and the system architecture, how things are connected together, will evolve to support that. And finally, the future is whatever you want. So the feedback that people who are using CUDA give us, that's what will drive the features and functionality that we add. So that's all I have prepared, and I think we're right at the time limit, but we could still take a question or two. Do we have any?
I have one here online. This should be shorter. Do you know any party that has plans to make something like a free CUDA Fortran compiler available? Obviously, you have PGI has a product they will gladly give to you for money, but
I'm not aware of anybody who's doing any free Fortran for CUDA, but it's probably only a matter of time. There are a couple of open source compiler efforts, which are free. So I'm for C and C++ and Python and other languages. So it has to become interesting for some university who doesn't have the money to buy it, and they'll do it. Other questions?
The question.
Another question here from NCSA. Insight's really nice, but a lot of us scientists work in a Linux world. So can you beg the software developers to port Insight to some sort of non-Visual Studio expensive format, please?
Yeah, we get this question a lot, and the first answer is we do focus on the other 99% of our business. So it's a challenge for us. The answer to the question, why don't you give Linux the support it deserves? And the answer is, if we did that, it wouldn't get off the ground because it wouldn't get enough support. It's not big for us. It's small. We do invest a lot in it, though, and we try to find partners. And there is a Japanese developer that has Yellow Dog Linux distribution integrated with a CUDA toolset, and they have a visual toolset that works with our pieces. But again, that's something you have to buy. You have to buy their whole environment. The name of the company is Fixters, Fixsters. The reason we're able to provide the wonderful functionality and the breadth of experience for the Parallel Insight is because it's implemented with Visual Studio, which does the other 90% of the work of the UI and the framework. So we would have to write that ourselves, and it's far beyond the size of our whole tools team to do that. The Visual Studio team is 20 times the size of our whole team. So I feel your pain. I understand the request. I don't see a full relief to the pain in the short term. So sorry. We'd love to help, but it's just too big. So there was a remote question, I think.
Yeah, there's one more question. Yeah.
Michigan.
Hello.
So we hear you, Michigan. Hold on just a moment.
As far as I understand currently and in the nearest future, there's only one way to input and output the data through the PCI bus, right?
The PCI Express bus, that's right.
Yeah, so is there any plans to like increase this speed of transfers between the GPU and the outside?
Well, so
like you said, LANs, like InfiniBand, as you said.
So just want to make it clear, if you look at a PC architecture, the fastest bus on the PC is the GPU memory interface. The second fastest bus is either the PCI Express or the front-side bus. The next fastest bus is probably the system memory. And then after that, you get way, way down to network speeds and disk speeds and other kind of device speeds. So everybody has in their mind that PCI Express is a big bottleneck. But I think that's primarily because you have to manage it transfers yourself. The throughput turns out not to be a bottleneck in very many programs that we analyze. That being said, PCI Express is getting faster. It's going to go to PCI Express Gen 3 pretty soon. And also, you know, there's the potential for peer-to-peer kind of communication, you know, directly avoiding slow interfaces like this system memory interface.
Okay, University of Michigan had a question.
Is there any plans to help integrate your CUDA tools with architecture based on LLVM or the Xcode family?
So that's a good question. I think I can't talk about specifics, but we are definitely trying to make our tools available to a wider variety of partners and developers. So I'd say watch this space. I can't give you any confirmation yet. Okay, and there was a question here in the back. If so, the question is, do I know if Nsight works with the free Visual Studio? What is the free Visual Studio? Is that the pirated version, or? No. I don't know. I don't think so.
UCLA has a question.
Okay, go ahead.
If you have a student qualified domain, if you have an EDU qualified, an EDU domain qualified email address through DreamSpark, you can download the full version of Microsoft Visual Studio and use it for non-commercial purposes. The absolute full version, and it will work with it. I've used it before.
Excellent. Thank you for that. Could you please post that in the forum at NVIDIA? Because we get that question a lot. Okay. If there's no more questions right now, thank you very much.
I have one more from online.
Oh, one more.
Are there any plans by anyone to implement CUDA on AMD, ATI, or traditional CPU hardware?
Well, I can say, separate from plans, there's already several ways to execute CUDA code on other devices. There is a tool, and I'm going to mix up the names of these tools. There's a tool that translates from from CUDA source to OpenCL source. Is that Ocelot? There. Maybe John, you can answer this. You probably remember the names.
This is actually my area of research, so I can answer some of these questions. There is a tool in development by our research group, Wenmei's research group here, to convert CUDA code to OpenCL. There's also the GPU Ocelot project. I don't know exactly what that does. There are several different things it does. One is, I think you can install essentially a CUDA architecture emulator on your CPU hardware so that you can just run your CUDA code and it will JIT the PTX to native x86 assembly and just emulate the CUDA architecture that way. Beyond that,
Ocelot has an emulator target, and it also has an LLVM target, and they're working on some other targets as well. So Ocelot is actually pretty fast.
Yep.
So I guess the answer is, you're asking me this question, but we build a processor and we built a tool chain, and it's pretty much open. And so why don't you ask AMD and Intel and anyone else who makes processors, why don't you support CUDA? Why don't you make some tools?
Yeah.
Northwestern has a question.
Northwestern.
There's a question from RSU.
All right, let's start with Northwestern.
Okay, in the forums, perhaps, could you post an example of using printf in a kernel? I've spent a lot of time trying to figure out if that's possible. I mean, I'm running the SDK 3.1.
Post a question using what? Post an example using what?
Printf.
Printf.
From a kernel.
Okay. All right. There should be an example in the SDK. 3.1 SDK.
Okay. Well, nonetheless, if it's possible to get an example, it would be really helpful.
Yeah.
In the forums here.
Yeah, we can post an example on the forums for this class on using that.
Okay.
Thank you.
And LSU had a question?
Yes. I'm a little bit interested in the instruction set. Can I ask, what is the little difference between instruction set supported by Fermi, the GPU architecture, or the traditional CPU architecture? Thanks.
Well, we don't publish our instruction set because it changes 20 times a year underneath PTX. It's implementation dependent. It changes a lot. The difference between our instruction set and CPU instruction set at a high level is CPU instruction set is designed to run a single thread as fast as you can. Our instruction set is designed to effectively execute many threads at the same time. And so we're really not trying to do the same thing, so the instruction sets don't look like the same thing. And
thank you.
One of the other reasons we don't publish it is we want AMD and Intel to figure that out for themselves.
All right. I think we'll have to cut off questions here for time. So the next thing is up to your local schedule, reconvening at the normal time, roughly 50 minutes from now.
And thanks,
David Kirk. Yeah, and thank you very much, David Kirk, for that talk.
Thank you.